Thank you. So I will present to you a work I realized with a French colleague, Egon Ostrosi. It will be better for you than Egon presents, because my English is very, very bad. I'm sorry. So I read the text for your comprehension. Your meaning. My research since 20 years is on agent for modeling and simulation of complex systems. And I work with Egon Ostrosi since 10 years in a particular file on manufacturing and design. My presentation follows this plan. I begin by present work context, and after I present Holonic fuzzy agent modeling, then I present you virtual manufacturing cell formation, and then I present a case study on manufacturing cells formation. And finally, I finish by presenting some conclusions and perspectives. Sorry, I read my text. It's better for you. Our paper addresses the formation of virtual intelligent manufacturing cells in cloud-based design and manufacturing. It assumes that cloud-based design and manufacturing can be referred to as a dynamic service-oriented network where a set of CAD parts modeled by a set of features can be manufactured in intelligent virtual manufacturing cells under certain constraints. Features can integrate product data with manufacturing data for cell formation problems. Holonic and the fuzzy agents are used to create this dynamic service-oriented network, digital design and manufacturing. The proposed agents face, feature, constraint, part, machine, and cell incorporate the functions of observation, decision, and action, as well as possess their own knowledge. Being aware of the geometric and topological context in a CAD environment, the feature agents interact to create a dynamic network between part agents and machine agents. Sorry. The machine agents interact with the part agents to recognize each other and to form specific sub-communities called virtual manufacturing cells with Holonic structure. In order to capture the dynamic aspects that characterize manufacturing in the cloud, this research introduces the concept of the attractor. In our case, an attractor is a structurally stable part or machine Holonic agent in cloud-based design and manufacturing. Finally, introducing the concept of the attractor, integrating the uncertainty in the modeling of Holonic fuzzy agents, this paper proposes an approach to address intelligent virtual manufacturing cell formation in cloud-based design and manufacturing. In a previous research, we applied the concept of Holonic in cloud-based design for configurations. Now we adapt it to virtual manufacturing cell formation. The main interdependent properties for holons inferred from this research work are self-similarity, self-organization, self-adaptation, self-expansion, and emergence. Let's start by defining the Holonic fuzzy agent model. A fuzzy agent-based system is defined by a 5-tuple mu where alpha, iota, rho, and omicron are respectively a set of fuzzy agents which can be grouped to form Holonic fuzzy agents, for example, a set of fuzzy interactions between fuzzy agents, a set of fuzzy roles that fuzzy agents can perform, a set of fuzzy organization, for example, subset of strongly linked fuzzy agents or Holonic fuzzy agent presented in this paper, and phi, a set of functions of fuzzy agents generation. The behavior of a fuzzy agent is a basic cycle: perceive, decide, and act. It is described by a four tuple where phi p, phi delta, and phi gamma are respectively functions of observations, decision, and action of the fuzzy agent. The set of knowledge, kappa, of the fuzzy agent includes decisions, rules, objects, and characteristics of the domain with their values, for example, the geometric and topological attributes, acquaintance, for example, a set of fuzzy agents from the same Holonic level, and dynamic knowledge, for example, observed events. A set H of Holonic fuzzy agents is defined recursively as follows. Each fuzzy agent forms an atomic Holonic fuzzy agent H. H is composed by a four set of fuzzy agents and a relation R. H' is a set of Holonic fuzzy agents that participate in H, and H0 is a non-empty set of Holonic fuzzy agents that represent H to the environment and is responsible for coordinating the action inside H. And R defines fuzzy relations inside H. R, in fact, specifies the Holonic fuzzy agent organization. Now we can apply this Holonic fuzzy agent model to the specific problem of intelligent virtual manufacturing cell formation. In this case, the faces, the features, the parts, the machine, and the cells are fuzzy agentified. Then from fuzzy agents part, machine, and cell, Holonic fuzzy agents are generated. Any manufacturing feature can be characterized by a set of faces that satisfy a set of topological and geometric relations. Each face is transformed into a fuzzy face agent. This part was presented at 2 years ago at TNCE 2016. The first proposition of our work postulates that the intelligent virtual manufacturing cell should have the structure of the holon. The second proposition of our work postulates that intelligent virtual manufacturing holons tend to evolve towards some particular physical elements, parts or resources. These are called attractors. An attractor is a structurally stable element, product or resource in cloud-based design and manufacturing. In the paper, we present the distributive algorithm of virtual cells recognition executed by each Holonic fuzzy part agent. I have no slide on this algorithm. It's too complicated to describe for me. The main four recursive steps of this algorithm are the fuzzy attractor identification first, the attraction of parts alone, in second, the attraction of fuzzy machine alone, and the fourth, in fourth, the formation of a new fuzzy manufacturing cells with part allowance and machine allowance. And we repeat again. So I present to you a case study, a little case study on Holonic structure of cellular system. A set of manufacturing features and their corresponding operational features are shown in this slide. Six parts with their features. Based on manufacturing feature recognized by fuzzy agent interaction, the relationships between a set of part and machine and their corresponding operational features is shown. For example, you can see in the matrix that the part P1 is composed of the feature X11. And we can see that the machine M1 can manufacture these features with a coefficient, a weight of 1. And for example, this feature with a weight of 0.8. In this case study, there are 3 levels of Holonic fuzzy cell agents formed during the recognition of intelligent virtual manufacturing cells. For instance, in the second level, here and here, 2 Holonic fuzzy cell agents are recognized. The first Holonic cell agent, C21, is composed by part agent P21. In fact, the Holonic C21 is here, and the machine M21, and related by the fuzzy sub-relation here to 1. It's the relation. This Holonic fuzzy agent network shows the Holonic structure of cellular systems. Then the group of manufacturing feature agents to be manufactured in each cell agent can be inferred. You can see here the part on the level 1, on the level 2, and on level 3. Consequently, each new part agent involving these feature agents can easily find the corresponding cell agents. Now I present you some conclusions and perspectives for this work. This paper proposes an approach to address intelligent virtual design and manufacturing cell formation in cloud-based design and manufacturing. The face feature constraint part machine network modeled by Holonic fuzzy agents offers a promising solution for next generation of intelligent virtual manufacturing cell in digitalized networks. Further developments, there are numerous, include the study of the dynamic behavior of intelligent virtual manufacturing cell in digitalized design and manufacturing network. For instance, in cases of creation or destruction of attractors identified and defined in the Holonic fuzzy cell agents. Thank you, and sorry for my English.
Okay, ladies and gentlemen, any questions for Alain-Jérôme?
In the paper, you find the algorithm.
Yeah. There was a slide defining Holonic agents.
Yes.
So can you define what the Holonic agent and the fuzzy agents mean basically? The self-organization.
Yes.
Self.
Yes. Is
One more before. One slide before when talking about
no,
self-organization.
it's
One more before probably. Yes. The self. So what is this? It basically defines the agent or what?
no, it's
So the
only
properties of holons, right?
it's only the properties that interest us in the Holonic concept, because we can consider self-organization, the possibility. For example, if a part machine attractor.
Yeah, these four are clear. So what self-similarity means?
Well, you can compare some Holon. In fact, imagine in the cloud the possibility to have different manufacturing cell, okay, with characteristic with same characteristics, and if a machine are not disponible, not usable at a time, we can change the cell, the manufacturing cell, with a same organization of the cell. Self-adaptation, organization, self-expansion is a capacity to have a lot of machine and part in expansion.
Okay, Duncan.
If we want an example of self-similarity that's not like multi-agent, think of a fractal, so the structure of the small of a part of it reflects the structure of the whole of it. So that's what the self-similarity means, is that the overall structure you get in the collection is replicated on a smaller scale in a component of the whole.
No, do you mean the topological equivalence?
It could be, but it's not limited to that. As far as I understand, the concept is very broad. I'm just giving you instances and as an example of self-similarity.
Yeah, I mean, one way to express self-similarity could be establishing topological equivalence.
I think so, but I don't think it's limited to that. I think that's an instance. Yeah.
Okay. Thanks.
Okay, any more questions at this stage? Good, thank you very much. Let's give him another hand.